Welcome to Multiple Choice Monday number 10. So this question was comparing the boiling points of two compounds, HCl and HBr. And they told you that the boiling point of HCl was actually lower than that of HBr. Be careful that you don't get swayed by these negative numbers. And we're asked to decide which bonds or intermolecular forces are responsible. And the correct answer is London forces. So let's explain why that is by going through our options in order. So HCl and HBr are both covalent molecules. So they have the same type of bonding and they have the same type of structure, which is molecular. And what we mean by that is that there are no bonds in between two HCl molecules, for example. There are only intermolecular forces. So that means that we do not need to break covalent bonds in order to boil HBr or HCl. So A is definitely wrong. We would only talk about covalent bonds and melting and boiling points if we were considering a covalent lattice such as graphite or diamond. What about hydrogen bonding? Hydrogen bonding only occurs when the hydrogen in a molecule is attached to oxygen, nitrogen, or fluorine. So we're looking for OH, NH, or in the case of the hydrogen halides, HF. That is not what we're talking about here, so hydrogen bonding has got nothing to do with our answer. So that leaves us C and D. Now, HCl and HBr both have two types of intermolecular force. So they both have permanent dipoles because they both have permanent dipole bonds. They have a delta plus on the hydrogen and a delta minus on the bromine or the chlorine. And they also both have London forces, which you may also know as van der Waals forces or instantaneous induced dipole attractions. So the question is, which one of these is responsible for the fact that HBr has a higher boiling point? And that's the key thing. So if I was to consider the permanent dipoles, the HCl bond would be more polar. That's very rarely a reason for a noticeable difference in boiling point, however. So if you were comparing two molecules where one of them had a permanent dipole and the other one only had London forces, then it would be likely that the one that has the permanent dipole may have a higher boiling point. However, the size of the molecule is also really important, and the reason the size of the molecule is important is because it affects the number of electrons. And if there is a large difference in the number of electrons, then the strength of the London forces will be quite different. And therefore, a molecule with very strong London forces could have a much higher boiling point, even if it's not as polar. So the reason that HBr has a higher boiling point is because it has stronger London forces, and that is simply because there's quite a large difference in the number of electrons between a chlorine atom and a bromine atom. So a chlorine atom has 17 and a bromine atom has 35, which is more than twice the number of electrons. So there are more instantaneous induced dipoles being set up. So you want us to know more, especially if you want to really improve your game in bonding structure and intermolecular forces. I've got my live online masterclass this Saturday at 12 p.m. and there are just a few spaces left. My masterclass is £10 per pupil and there's limited to about 10 to 12 pupils. However, your first class is free, so if you want to get in there, send me a message ASAP. Also, don't forget, if you are taking A-levels this summer and you're in year 13, download your chemistry revision planner now. That will give you lots more information about resources to help you revise. And of course, you can go to my website for some more exam style questions and explainer videos.